Hi, welcome to Azure User Group Sweden. I'm back. Hi, Håkan.
Good morning, Jonah. How are you?
I'm good. I'm good. I wish we had a better weather here in my side of Sweden, but it was great yesterday, and I'm happy to be back in this session. I will miss the last session with Tore, but how about you? How are you? And the
Yeah,
weather
actually,
in Oslo
yesterday
today?
was plus 19, so it was almost a summer day. But
Yeah.
today it's stabilized or normalized to more of a cloudy, very windy day.
Yes, I can relate to that. I think my dog Lawrence was also could relate when we went for a walk this morning. Yeah, but hi everybody. Welcome back to Azure User Group Sweden. It's Saturday midday. We're live actually right now, and we're here to have a session with an interesting topic about Azure Front Door, which many organizations or many of us can relate to during the last outage that happened last year, October 2025. And I'm very eager to learn from this session as well. And our guest speaker is also an Azure MVP. He is a community leader and he's going to join us live. He's in backstage right now and is joining us from Portugal, in warm weather, Portugal. So before I start, let me present my co-leader, Håkan Silvernagel. He is my co-leader at Azure User Group Sweden. He is an Azure AI architect at Soprasteria. He is one of the community leaders of Norwegian.net User Group, AI School, AI 42, and MCT community lead like me, MVP as well. And it's an honor to have Håkan to work with for the past 5 years, which is actually the anniversary this month of our user group. So thank you, Håkan, for being my collaborator for the last 5 years. You've been there since the start. I mean, I was
Thank
alone
you.
from the start.
Thank you so much, Jonah, and thank you for this time here. And I'm also very honored to present Jonah Anderson, who is the founder of our user group. And in addition, she's also an Azure MVP and a Microsoft certified trainer, an international public speaker, and a podcast host. And she's also the author of Learning Microsoft
Yes,
Azure on O'Reilly book. And she works
thank you.
as a senior Azure consultant for herself on her own company, Jonah Anderson Tech.
Yes, thank you, Håkan. And welcome, everybody. I see a few of us saying hi. I know that I posted or announced the event a bit late. So I look forward that there will be many that will watch this session and the recorded one. And it's also Saturday. So we understand that it won't be many live viewers, maybe, but it will be a fun also to learn. We have a few people saying hi, but before we start, let me go ahead and show our code of conduct. At Azure User Group Sweden, we are part of Azure Tech Groups around the world. We're representing Sweden, at least the north side, and we follow a code of conduct. We expect everyone to be nice and friendly, be respectful to others, and be curious to share your ideas if you have any in our live chat or during our after session fika. Be inclusive with your comments and be careful also if you have ideas related to the topic. It's always good to learn from each other. And then we also have a fika session, Håkan, right? Let's see. Where is the fika? Here. Fika session. We usually organize like a 15-20 minute after session Zoom meeting, private, between us, the organizers, and the speaker, in case we run out of time and you have kind of like one-to-one questions to us related to the session or topic that relates to your work or questions. So that's it for me, Håkan. Would you like to have the honor to announce our guest?
Yeah, so we were happy here to have our guest here, Pedro Sosa. Let's add him here to the stage. Welcome, Pedro.
Hey, good morning, everyone.
How are you?
I've exhausted my Swedish. Hey, it's the only word I know in Swedish. So
Oh, I know some Portuguese. Obrigado, obrigada.
yeah, that's true. So
Uh, yes.
obrigado for inviting me to your user group. I'm really, really glad that we are here for this session. And I see some people here on the chat that I know. So thanks guys for also showing up. I hope you enjoyed the session. I hope you like it. Like Jonah was saying, I'm from Portugal, and today we have clear blue skies, sunny weather. So yeah, I'm excited to do this for your user group.
Yes,
That's great. I guess before we start the session, we could just have a more formal introduction here to Pedro for those who doesn't know you. So Pedro Sosa is a Microsoft Azure MVP, a public speaker, and an Azure tech lead with more than 30 years of experience in IT, managing infrastructures ranging from small mission critical to 1,000+ user organizations. And in the last few years, Pedro has worked in DevOps practices and as a cloud architect, leading teams to design and implement solutions across the Microsoft and AWS stacks, focusing on cloud-first or hybrid scenarios. With a passion for technology, he's always looking for the next big thing because cloud is candy store and it never stops evolving.
Yeah, it's been a while since I started in IT, true. More than 30 years. I've seen a lot since the days of MS-DOS and putting a floppy disk to boot your computer to cloud, right? And in cloud, it's always evolving. We've been using Azure since the early days, the early beginnings. I still remember that those first portals, the ASM portal with just a few services, and it's grown a lot in terms of what you can do and what type of resources you have available. So yeah, I feel it's like a candy store, right? Every time you look at Azure, there's something new to experiment, there's something new to try. And yeah, we are fortunate as MVPs to have early access to a lot of things, to try it out, to kick the tires, as I usually say, to kick the tires prior to everyone, and to help also the technology evolve. I've been part of the team that developed Bicep in the early days. I was engaged with Azure Blueprint. I was one of the first. Azure Migrate also. There's a feature on Azure Migrate that was created because of me, because of the scenario that I had at that time. And when you look at these technologies and you see that there's one little thing there, here and there, that you influenced or that you helped create, and that is amazing. That's something.
Yes.
Anywho, I don't know. Do you want me to kickstart the presentation?
Yes. I just want to say that I'm very glad that we made it to organize a session in my user group, because I know that you, Thiago Costa, and you are two of the community leaders that I know in both Lisbon and Porto that organize your user group as well. So you are one of the leaders of Azure User Group AI Portugal as well. So the other side. So glad to finally have you. And there's more. Definitely, you know a lot about Azure. So I think I'll consider you as my tech reviewer in my upcoming book. But I'm excited to learn about Azure Front Door, because I myself has been working on it at my client. So let's hear. Do you want to share your presentation?
Yeah, let me start by sharing my screen.
And as always, if you have any questions there, just put them in the chat and we'll take them on the ways or at the end of the session.
Yes, I also see Jose Costa from Angola joining us here. Hello.
My dear friend Quintino is here.
Lots of common friends supporting each other and learning from each other. That's great.
Okay, you can see my screen, right?
Yes.
So let's kickstart this. Today we're going to talk about Azure Front Door, or better, how we can harden our edge, how we can improve our resiliency to outages. This session is about front door, but what we are going to talk about will cover also other scenarios, right? When I've designed this session, when I thought about this session, and because, as you know, I'm a Microsoft MVP on Azure, I thought about Azure, but you can also look at this with other CDNs in your mind. Okay, so but we'll talk about it a little bit later. Let me just advance. So, like Jonah said, I'm a subject matter expert at Vaultec. So basically, I'm an expert on cloud, especially Azure, but also AWS at Vaultec. Vaultec it's a global enterprise. We work globally, even in the Nordics. We have some offices in the Nordics. I manage the European cloud team. So it's a team of cloud engineers, site reliability engineers, DevOps, big quotes there, DevOps engineers, because for me, DevOps is not a job title. It's a philosophy, it's a way of working. But anywho's, DevOps engineers. And my team spans from Portugal to Southern and Eastern Europe and Northern Europe. So I have 28 engineers that I manage across several countries. And that's what I do professionally. I help my customers with architecting their solutions, my guys and girls to deploy the workflows that we design, etc. Also, I'm a Microsoft MVP, as was mentioned before, on Azure, but also on developer technologies. I do have two categories because working with developer teams, working with the type of environment that I work with, I also do a lot, not only on Azure, but also a lot of sessions on GitHub. Nowadays, AI also, GitHub Copilot and stuff like that. But anyways, if you want to know more about me, you have the links there, or the QR code that has my contacts. If you want, feel free to send me a message on LinkedIn or send me an email. The only thing is, don't expect immediate reply, okay? But I will reply if you send me a message. Anyways, let's start this session. And why this session? So I've put here some clips that I took out of the news about recent outages that we had mainly last year. And as you see here, it's not only Azure and Azure Front Door, but we also had major outages on AWS. We also had major outages on Cloudflare. And all of this impact our workloads, impact our ability to provide services online, right? So, like I said, we are going to focus this session on Azure Front Door. So let's talk a little bit about Azure Front Door. So Azure Front Door is the global entry point for several services of Microsoft. Services like, for instance, the Xbox service, or even Azure Portal. Azure Portal is also served to our browsers, to us, through Azure Front Door. And one of the outages of last year, a lot of people noticed it was failing because they wanted to access the portal and they couldn't. So they couldn't interact with their cloud resources in that way. Other than that, it's also the entry point for thousands of enterprise customers that have their workloads on the cloud. Azure Front Door is spread across roughly 210 points of presence worldwide. And yeah, October 2025 was a tough month for the Azure Front Door team. two global incidents that affected a lot of customers worldwide, mainly in Europe and Africa. So how does this work? How does Front Door work? Before we go to the accident itself. So Azure Front Door, like I mentioned before, it's a large-scale CDN, right? And when we use Azure Front Door, when a customer uses Azure Front Door, we configure our endpoints, we configure WAF policies, we configure our routes, and those configurations that we do as customers are then distributed globally across the entire fleet of servers that serve our workloads through the global CDN. This architecture is basically defined in this way. So you have what's called a primary ring, and the primary ring is used to serve, it's a primary server of our traffic, of our endpoints. That primary ring is distributed across several edge sites. Within each edge site, then there's a bunch of racks, and within the rack, there's a bunch of servers that serve the cache. On those servers, there's different roles. So you have one of them, which is the master, that is the command and control of that cluster of servers serving a Front Door. This is also important, the fact that there's a master and there are edge slaves on that cluster, but we'll touch that a little bit later. So there is this primary ring, and then you have your secondary ring that acts as fault tolerance for capacity. So whenever a huge volume of traffic, a huge volume of requests is sent to the primary ring, if that load is too big, then Microsoft distributes the load to a fallback ring. So it creates some fault tolerance, but also some load distribution. And then if that is not enough, then there's some traffic spray. So some traffic is also spread across other rings, other servers, other racks to handle the entire load. So basically, this is how it's configured, right? The key point here is we have the rings, and within each ring, we have several sites, and within sites, we then have the racks and the clusters within those racks for the servers that are Azure Front Door. So looking at 2025 was, like I mentioned, it was a bad month, right? 2 outages, one October 9th, and another one 20 days later, October 29th. So let's talk a little bit about the first one. The October 9th incident actually was caused not in October 9th, but 2 days before, October 7th. October 7th, there was some metadata that was created on the control plane of Azure Front Door. We'll talk about control plane and data plane in more detail a little bit on the next slide. But there was some metadata that was created, and that metadata was incompatible metadata, so it was bad metadata. Okay, the control systems of Azure Front Door, when Azure Front Door receives a configuration, it has what's called the config shield. So it's a protection layer that looks at that configuration, and if it sees it's not good, then it blocks the configuration. And that was what happened. The config shield on 7th of October received that bad metadata, and it blocked the metadata from propagating across the fleet. Problem was that on October 9th, there was a manual cleanup. So an engineer, someone, was performing the manual cleanup of that bad metadata. And guess what? Yeah, the manual cleanup bypassed config shield. And by bypassing config shield protection, and this was due to a bug, with that bypass, it meant that that configuration started the replication process across those rings that I was mentioning before. And it started propagating across the fleet. Unfortunately, it reached the next stage, and then it was applied, and then reached the next stage, and it was applied, and it caused a data plane crash in more or less 6% of the fleet for Europe, and also 16% of the fleet for Africa. And with that, all of the customers that were in these two regions that were served by those servers. It was bad. It was bad. Of course, it took some time to recover. A lot of services were not available, but the problem was solved. Then October 29th. October 29th was a little bit different. So whenever you interact with Azure Front Door, either through the portal when you do click ops, like I like to mention, or if you use infrastructure as code, Bicep, Terraform, or you use AZ CLI and use the APIs to interact, you are sending configuration to the Azure Front Door, right? And what happened here was a customer sent configuration changes to Azure Front Door, and those configuration changes were valid, perfectly normal configuration changes. So this was not some action that the customer did that was faulty. What it did was perfectly normal, but unfortunately there was a bug, there was a problem, a latent problem within the layers of the control plane, data plane layers of Azure Front Door that was not known. And with this change that was requested by this customer, it had some incompatible metadata. And that incompatible metadata triggered the latent bug that existed on the infrastructure. The big problem here was the health check, so the config shield that I was mentioning before. The health check it exists also between each of the layers, each of the rings, and it works in async mode. So the config shield sends a request for validation of that metadata, and then it would continue to send further tests without waiting for the result. It's expected that the results of those tests, even though it's async, that they don't take a lot of time. But triggering this bug, it meant that it actually took more time than expected. And the health check not receiving the results allowed the configuration, because of the X amount of time, allowed the configuration to propagate to the next ring. That also created another problem, because when the security measures of Front Door received a reply saying, hey, this configuration is bad, the metadata had already passed to the next level, to the next ring. Whenever a configuration passes from one ring to the other, at the end of the stage, that configuration is saved as last known good. So from the start, I have a configuration, enters one ring, it's being checked. The check allows that configuration to pass to the next ring, writes last known good. Last known good is used, as the name says, it's the last good configuration that the system, that the ring knows. That last known good got corrupted because it was written with invalid metadata. The configuration already passed to the following ring. So you want to roll back, you try to roll back from the last known good, and the last known good is applied again with the valid metadata, and you enter this crazy loop of crashes. That was a global outage, and it was very hard to recover. It implied a lot of manual actions, especially because all of the automated fail safes and recovery systems were based also on the last known good, and it was damaged. Just to explain a little bit more, so I've mentioned data plane, control plane. Azure Front Door has two layers. One where we access front door, which is the control plane. Here whenever we do a change, either via portal or with the APIs, that control plane will take our actions, our clicks, and will change those actions into configuration metadata. And that configuration metadata is then sent to the data plane, and the data plane is responsible of applying that configuration and then distributing the configuration across the entire fleet of Azure Front Door. So this is how it goes in a nutshell. Okay, so here you can see a representation of how it works, and you see on your left, you see the control plane, and then the configuration being turned into metadata, which is then passed to the deployment service for the data plane, and then you see all of the stages. So you see there pre-canary, and then there's a stage, and then you see canary, and then another one, and then stage one, and one after the other. Those stagers that you see within each level, they have the control plane, they have the health probes, they have the checks, and it's also these stagers that are responsible for, if a need of rollback, they are responsible for not only saving the last known good, but also applying the automated rollback of the last known good if needed. Okay, so before I explain this slide, let me go back a little bit. So I mentioned in the beginning that we have a master and a slave within the cluster. Okay, so imagine you have one server that receives the configuration for that cluster, and that cluster, that server is responsible for the entire group of servers. One of the things that happened was, in the previous configuration, whenever a master received a bad configuration and that master was not working properly, the system would consider that entire cluster as non-functional. In these accidents, what happened was the masters started receiving the bad configuration. They were out of service, but their slave nodes were still working properly. But the system was implemented in a way that the entire cluster was considered bad. One of the changes that Microsoft did already was to change this behavior. So now, even if a master would take some bad configuration, if they see that the slave nodes, are still working properly, they don't remove the slave nodes from their work, so they can continue to serve traffic. They continue to serve traffic to the fleet, to the internet. So this is one thing which is important: the decoupling of those worker processes from their master. Another thing that introduced is, you remember the time when we had kings and queens, and they used to have someone that would taste their food to see if it didn't have poison or something like that? Well, they've implemented the same principle, the food taster. So within every cluster, there is now one machine, which is the food taster. And that isolated process, it's not there to serve any traffic. It's just there to receive the new configuration, apply it to itself, and see if it's good. And then, only then, it passes the configuration to the master node. Okay? If it dies, this food taster has no role, no active role in serving traffic and making front door work. It's just there to taste the food, and if it has poison, to die, not allowing that specific cluster to crash. Another thing is the validation improvements. So the async mechanism, the way that the configuration was, the metadata was tested, the validations, now it's not asynchronous, is synchronous. So yeah, moving to full synchronous configuration allows for issues to be detected sooner than later, so it's also more predictable. Problem with this, with all of this sync, I don't know if you tried in the last 2 or 3 months to do any front door configuration. Now it takes between 20 to 40 minutes to change something. So yeah, let me pause here for a bit before we continue, because I see Jonah sent me a question: Azure Traffic Manager and alternative CDN providers as a backup strategy, but Traffic Manager is also DNS based, RFD and Traffic Manager dependent. Well, you know the joke, right? When something fails, it's always DNS. Yeah, it's DNS based. So if DNS fails, then you have a problem. True. It is what it is, right? The only thing you can do is have different name servers spread across multiple regions. So if your name server, and Azure does that, right? When you use Azure DNS, you have 4 name servers on your zone, and the 4 name servers can be spread across. You don't control that, but they are spread across the globe. There's not much more you can do because it's, like you mentioned, DNS based, right? Anywho's, let's see what Microsoft proposes as a solution, right? So Microsoft has 2 documents. I can then share the links with Jonah, because this is public documentation, and also the link where these accidents were explained in Microsoft blog. There's some more details about this that I don't have the time to show here or talk about it, but there's some interesting details there in one blog post, and also the blog post links to technical details of both the accidents. So if you are curious about deep diving into this, it's available. Also, by the way, one thing that I think it's important, I don't know if you know, but Microsoft, whenever there's one of these major incidents, they host online meeting with the teams explaining what happened. Those meetings are usually it's per invite, and usually they invite customers and people that were affected by those outages, but also they are available then later online on their YouTube channel, so you can go there and there's a playlist with all of those meetings where they're explaining what happened and what you're doing to solve the issue. Anywho's, going back to these solutions, first solution that we have is this one. So what do you see here? Imagine that you have your CDN, your Azure Front Door, serving something, and your something are your application servers back, right? What you can do to prevent an outage or be more resilient if Azure Front Door fails again. The solution here is you can have a second CDN. And that second CDN can be, I don't know, Cloudflare or something else, right? And then you put Front Door in front of both solutions, and your Front Door, no, Traffic Manager, sorry. You put Traffic Manager in front of your CDNs, and your customer connects through Traffic Manager, and Traffic Manager then sends the traffic, in this case, through Front Door, because Front Door has precedence. This is a weighted mode, always serve configuration for Traffic Manager. So all the normal traffic will go through Front Door, and then from Front Door it goes to the backend applications, the backend servers. I'm going to show you something similar to this, not with another CDN, because I didn't have another CDN. I'm going to show you the second scenario, but they are quite similar, okay? This scenario will help prevent the problem if Front Door fails, okay? I'm looking at this from Microsoft Azure's perspective. So Front Door is my primary endpoint, my primary receiver. But if you are not using Front Door, for instance, you're using you use Cloudflare in front of your applications, you can also apply this scenario having your other CDN, for example, Cloudflare, as your primary and having Front Door as your secondary. So in case of an outage from Cloudflare, then your normal traffic doesn't go to Cloudflare, goes to Front Door. Okay, so you can swap this, or you can have even 3 configurations if you wanted. Okay, one small caveat with this: CDN is cache, has cache. So the problem with this scenario is your traffic is going through Traffic Manager, and the cache is filled with data on Front Door. And most of your traffic, we want, when we use CDN, we want it to be served from cache, right? So it's being served from Front Door to the client. When you do the swap, so imagine when Front Door crashes and your client's traffic is going through the other CDN doesn't have the cache filled. So your requests the requests from your customers are going to be served by your application servers. Okay, so when the swap exists, one problem, you don't have cache being or requests being served from the cache until after X time. Also, all the requests are going back to your origin application servers, which means that if you use mechanisms of lowering the compute on your application servers, you need to make sure that if this happens, they are able to serve the requests. There's ways of doing this. You can use mechanisms of auto-scaling to allow them to scale for a bit while they are serving the requests, and then scale down when the requests are served from the new CDN. But just be aware of this, this caveat. Second example, this one is similar. You see here 2 traffic managers. I'm going to show you this one, not with 2 traffic managers, only with one. Similar scenario. You have a traffic manager. Traffic manager has configured front door as the primary. Primary goes to the origin servers. And then you have a traffic manager configured to application gateway, and then application gateway to the origin servers. It's a all Azure solution, so there's no third CDN here, or second CDN here, better said, and has the caveat of application gateway does not have CDN, does not have cache. So here, it's even more important that your origin application servers are able to handle the load in case of a fault of front door. Okay. Well, instead of talking about it, why don't we see it in practice? So, to explain what we have here, let me put this font size a little bit bigger. So I have one web app. I'm using web apps. It's a simple service. I have one web app which is hosted in UK South. The same web app also on North Europe. So if I go here, I know that it says AKS ingress test on the title. This is because I have this application, this Node.js application that I've built, a simple application that just helps me test Kubernetes when I need to create a new cluster and then configure the ingress controllers, etc. I usually, the first workload that I deploy, it's this simple app. It's very small and gives me some information, simple information about if everything is working properly. Okay. For the sake of this demo, I didn't change the application or change the titles, whatnot. That was not important. What it is important from here is, you can see here, this is the app that's running in UK South. Okay. Also, this is the other one running on North Europe. So these are my 2 web apps. In front of these web apps, I have, oh, this is my traffic manager. I have my front door. So this is the page being served by front door. You see, this one was served through UK South. Let's try to do here some hard refresh. See if this changes. Usually I'm served from the same place, but sometimes when I do this, it actually changes the page. Yeah, well, not lucky today. So my front door is always serving me from UK South. I should change some settings on front door to make it swap from one to the other. But anywho's, this is front door. This here is my application gateway. So also serving from UK South, but this one, if we do some refresh, you notice here, you'll notice that it's swapping from one to the other because the application gateway is doing like round robin, one web app, another web app, another web app. So it's not looking at my sessions and session affinity or anything like that, right? So again, front door, back end of the front door, two web apps, application gateway, back end of the application gateway, the two web apps. And now I have here, where are you? I have here my traffic manager, and traffic manager is serving this from front door, okay? Let me go to my traffic manager to show you. So, well, front door first. So front door, if I go here to, you see my origin group. And as you can see here, sorry, as you can see here, these are my two web apps, one North Europe, another one UK South, right? Same goes for the application gateway. If I go to my backend pool, you'll see here also being served by the same two web apps on the application gateway. So let's look at the traffic manager, right? So traffic manager has two endpoints. Oh, I forgot to enable this one. I did some demos. I did some testing yesterday, and this one is disabled. Okay, let's enable it. Let's enable it. That's a pity because I'm going to explain why it's a pity. Let's do the tests in a little bit in reverse. So let me go here to my dashboards to explain to you what do I have here. On my dashboards, this first graph is the requests sent to front door. This one here are on the bottom left is the requests on application gateway. Here on top right, you have the cache hit ratio of Azure Front Door. Okay. Have you ever heard about K6, Apache K6? Apache K6, it's a small application that you can use to load test your systems. While I was talking with Jonah a few minutes ago, prior to this session, I've started a load test over my system. What you see here, this load test, I'm sending traffic to requests to traffic manager. And as you can see here at the bottom, all of the requests were sent to traffic manager and nothing was rejected, nothing was blocked, right? What I failed on this test was I forgot to enable front door on traffic manager. So it meant that all of these requests were sent to traffic manager and then application gateway. That was not the intent. My intent was to send this to front door, which I'm doing now. So I'm reloading this, and I'll show you the demo a little bit in reverse. So while this job is preparing, okay. While this job is preparing, so to give you an idea of what this is doing, it's creating 50 virtual users, and it's splitting those 50 virtual users into 5 batches, and every batch will run for 10 minutes. So I'm sending a lot of requests, sending a lot of traffic to my traffic manager. Right? What was expected was from my previous test, what was expected was all of the traffic to be served by traffic manager and then sent to front door. You can see here already, you see here a spike. You see here a spike on this graph. See, my requests are already beginning to, oh, now it's you notice very well it's being served by front door. The spike is huge, right? And if you look at the lower graph, you see nothing is going through application gateway. So here, application gateway is completely parked. Also, one thing that you notice is on this top graph, you're seeing most of my requests are being hit by cache. So Azure Front Door, it's doing its job, receiving the requests, and the traffic is being routed through front door. But let's play around. So my test is still running, right? So what happens if in the middle of my requests, my front door fails? So both of my endpoints are online. I'm going to crash front door. So now front door is disabled on my traffic manager. I don't have a way of crashing front door. So the only way is it's going to this endpoint and actually disable it, which I did. My tests, as you see here, my requests to traffic manager are still going. So let's go back to that dashboard. Continue to refresh and see what happens. One small detail. This is connected with Log Analytics Workspace. It's where I'm collecting these metrics. That takes a little bit of time to refresh the data. It's not real time, okay? Which means that these graphs, sometimes they take 1 minute or 2, or sometimes more, to actually refresh. Let me put this full screen. And yeah, auto refresh every 5 minutes. Let me put this full screen and see. While we wait for this, let me see what other questions we have here on the chat.
I actually have a question.
Yes, good question.
Can I ask a question? Well, I've been like looking into reading. I have a question. I think one of my I have a few actually, but one of the things I know about Azure Traffic Manager is that you can choose the routing type. In your use case here, did you use the priority base, or how did you configure the routing type when it comes to like Azure Traffic Manager choosing should I use CDN, App Gateway, or when something is down?
I'm using priority.
Priority based. Okay.
The use case is I want front door to always have highest priority in serving traffic, right? Front door is my primary endpoint. So I want all of the traffic to reach traffic manager and then go to front door. The other endpoint, which is in my scenario, my demo, is application gateway, or it could be a different CDN. I want it as only fault tolerance. So only if the primary front door fails, traffic is routed to the second endpoint. Okay?
Yeah.
To
Okay.
achieve that, it has to be priority.
Yes.
If
And you
you
can do
do,
on-prem as well, right? And no, you
yeah,
can route it
sure.
also to priority 3, depending on how you organize the priority.
Yeah, true. You could have something on-prem. Well, let's face it. If I have an outage and I have two CDNs, one primary, one secondary as fail-safe, I could have, for instance, simple application running on-prem that's just a landing page saying, hey, we are experiencing difficulties with our systems. We'll try to get online soon, something like that, right? It's better than having a browser returning an error or not returning your website, right? So you could have, for instance, that type of error page on-prem or somewhere else. And then your third scenario could be that. To give an example, we use when I say we at Valtech, we use Traffic Manager a lot. For these type of scenarios, we have in some customers, because we work globally, we have multi-region, which means that our workloads are not only in the United States, they're in Europe, they're in Asia, depending on, and they're load balancing. It's not only fault tolerance, it's also load balancing. Because let's face it, when you have a customer which works globally, their customers are from the US or from Europe or from Asia, right? So you route their requests to, in this case, I'm thinking about Kubernetes clusters, you route it to the workloads which are running in the clusters which are closer to them. So we are leveraging, in this case, it's not priority, it's weight-based routing.
Okay.
But also we use priority to have, for example, a simple static web page if I need to do a maintenance in a cluster in Europe. Usually the clients, the customers are routed to the US or to Asia, and we do the maintenance on Europe. And then you put Europe back online and you do the maintenance on the US, and vice versa, right? But also in some scenarios, we actually want to turn it off and say, we are doing a global maintenance and this is your landing page. And then you have a static web app, for example, which is that third endpoint that when you disconnect all of the others, that customer is going to land on a page saying, we are doing some maintenance, we'll get back to you soon, blah, blah, blah.
That's when you need to do the takeover manual manual override, right? When there's that thing. But thank you for that question. I have actually a few more, but I'll let you proceed with your demo.
Yeah, let
Thanks.
me go back just for a minute here. So what you are seeing on this graph is my service, my requests started to be served by Front Door, right? And then I've created that simulated outage of Front Door by going to Traffic Manager and disabling that endpoint. And what you see here is, first, you see a drop on Front Door. This is not immediate drop. So you see the curve going down slightly. And why is that? Because Front Door service actually didn't break. Right? I didn't break Azure Front Door. I cannot break Azure Front Door, unfortunately, or fortunately. I cannot break it, right? So a lot of requests that were already sent to Front Door, they were still in transit, they were still being served by Front Door, okay? If this was a real fail scenario, you would see like a hard line dropping the requests at Front Door. So Front Door continued to receive some requests while we were conducting the tests, but new requests, and you see it here on the bottom, right? The new requests started to be served by my application gateway, and it's still not visible, but on this cache it ratio that we have on front door, here we're going to see also a hard drop, a hard line dropping, because cache is not being used anymore to serve requests. Okay. Still refreshing the data, so let's keep this page open. Let me go back to my PowerPoint. So, like I've mentioned, this is well documented on Microsoft blog. Here, this first link, and I'll pass it to Jonah so she can put it on the description of the recording. This first document has, it's a public document from the Microsoft blog. It has all of the explanation of these two incidents. It also has links, these ones here, both of these, which are in-depth descriptions of those incidents. It's interesting to read because it explains a lot about what's going on within the data plane, within the foundations of the service. I don't know about you, but whenever I have a new computer or I don't know, a car or whatnot, I like to open the hood and look at the engine. This is also a way of opening the hood a little bit and looking at the engine that's serving Azure Front Door. And with this, we are done. I don't know if we have some more questions, but before we wrap it up, as I told you, you see here the hard line on the cache not being used anymore, and you can understand that these last requests were served by application gateway, not by front door. So yeah, I hope that you like my session. I hope that you learned something. And again, if you have any questions, if you want to ask anything, if you want to do any comments, whatnot, you can, let me put my contacts here again. You can reach out to me through LinkedIn or email. And on GitHub, some of these sessions, which I consider being able to be public, I also have repos on my GitHub that have the Terraform or the code that I used for this demo, so you can also use it yourself and deploy it to your Azure subscription and try it out yourselves.
Thank you. Thank you, Pedro, for the great session and for everyone that joined us live. We do have a feedback also from Jose Costa. It's about our user group. Thank you so much. Good to hear that we are an inspiration to you. Pedro, great session. I've learned a lot. I have like lots of notes. And I want to ask a question though, because I think this is a question that cannot wait. I think in our private Zoom meeting after, we're going to devote a bit of 15 minutes after we end our live stream for those that wants to spend time with Pedro, Håkan, and me to ask questions. I have a question. I think it's good to put it on our recorded live stream. And one question I have is that you did mention a few. You mentioned Apache K6 for load testing. We can take it later.
Mm-hmm.
But one important question is like that applies probably for everyone is like, if I need to choose an alternative CDN aside from aside from Azure Front Door, if it goes down, what is your, like in your experience, is the best alternative CDN that's a bit closer to Azure Front Door in the way how it works with backend pools? You know how it is. What's your preference, if based on experience or projects you've worked with?
We work a lot with Cloudflare. A lot.
Cloudflare.
Yeah.
Okay. Is
And
it good?
also, yeah,
Good.
it's what I like in Cloudflare. Okay, so rewind. We work a lot with Cloudflare. We work a lot with Vercel.
Okay.
Nowadays, because we work more, I don't know if you know about what the composable architecture is. We have we privilege our customers. They privilege a lot. We put the pages on Vercel on the edge, so you have your workload served not by web apps or something in the back end. You have something close to the customer on the edge serving the request. And for that, you can use Vercel, you can use Cloudflare Pages. So instead of having a web app on Azure, you put it on the edge, and then it's distributed by the CDN network of that provider, either Vercel or Cloudflare.
Okay.
What we have mainly on Azure are APIs, which those workloads connect to, APIs that then intersect, because we work a lot in commerce platforms and digital experience platforms. Those are the two big areas that we work for. In Azure, you have the APIs that then connect to other external services. I don't know, Algolia for search, Adyen for payment, connect to backend ERPs or CRMs like SAP or Dynamics or whatnot, right? So in many scenarios, we are not using Front Door as the CDN. We are using other types of CDNs. In some cases, we still have customers that use Front Door. True. Many of them actually use even Front Door Premium SKUs because of the WAF capabilities. But one thing that Front Door doesn't have is DDoS. If you want DDoS protection, then you need another service, which is Azure DDoS. And then the bill starts to pile up, right? And with services like, for example, Cloudflare, and that's why I like Cloudflare a lot, to be honest, you have that. You have the CDN, and you also have the DDoS protection on that service. So you combine everything there. What is a little bit harder or could be a little bit trickier is certificate management between what you have on Cloudflare and what you have on the cloud on Azure. It's a little bit, could be a little bit tricky. Also, in terms of security, you need to take some considerations that your workloads on Azure only communicate with the ones that are on Vercel or Cloudflare. So you have to take some measures there. But this is more or less the type of architectures that we build.
Okay. Interesting. Thank you. I have a lot of questions in mind, and it's very relevant topic for me because that's what I'm helping my clients also in my consulting work. But thank you so much. I won't take much of our time. For everyone, I see we have actually people watching us live. The common members, Takus Susuyama from Japan. Thank you so much, Pedro. Thanks for explaining the Azure Front Door incident as well. Now I have better understanding what it is. So thank you, Pedro. You've reached your information to Japan. So thank you for that. Håkan, did you have anything to say or share about the Front Door related to your work or any input? I think, did Håkan freeze? Oh, you're here. You're back?
No, I'm still here. I just had a glitch, so I didn't hear what you said, Jonah.
Did you have anything related to Front Door input that you thought you have experience in this?
I could just ask more of a beginner question here to Pedro. So for those who hasn't used the front door so much, do you have any like introductory learning material? For example, is there modules on Microsoft Learn or anything like that?
Well, on Microsoft Learn, you have a lot of documentation for front door. To be honest, it's kind of simple to use the Azure Front Door. It has a lot of capabilities, right? But in a nutshell, what you need to think is you have your entry point. So you have, if you look at front door as something with an input, something in the middle, and then an output, you have your entry point. So your FQDN where the requests are entering. You have on the output, you have the backends that are serving those requests. And in the middle, you have a route saying, if your request comes through this endpoint, then route it to that backend. That is in plain simple how it works. It then can be a little bit more complicated because you can, in the middle part and the backend, you can have, for instance, route-based or path-based routing, that's the term, where if the entry point is, I don't know, Azure User Group Sweden / about, it goes to a backend. If it is /learn, it goes to a different backend, so you can tweak this. WAF is pretty simple to enable. Bot protection only exists on premium, but on WAF, this is something you need to take into consideration and test. Some weird cases I've seen, we actually needed to go to the WAF rule definition, which is from OWASP. And those WAF rules are defined in the regex patterns. And we actually needed to take that pattern, look at our requests and see why they were being blocked, what was causing the blockage. It's not common scenarios, but sometimes it happens. Okay, so if you're enabling WAF, take care of the rules. Look at that. One piece of advice: a lot of people, when they see traffic being blocked on the WAF rules, what they usually do is go to the definition of the WAF and disable that rule. I don't like that approach. If your traffic is being blocked by that rule, then something is not proper. So try to figure it out on a lower environment, development or UAT environment, fix it, and then push it to production. Disabling the rule shouldn't be your first approach, okay?
Especially in production, not.
Yeah,
right?
well, sometimes you have to do it. I've done it.
Yeah,
I've done
worst
it
case
in some
scenario.
scenarios.
Yeah.
Disabling in production to allow that traffic to pass and then solve it on lower environments and then push it back to production. But
Yes.
it's,
Yeah.
I think, a common mistake I see with Azure Front Door or using Azure Front Door.
I need to tell my client that way. I'm in the mission for that. Good,
well,
good way.
we need to preach the good principles, right?
Yes,
So.
but I got a question. Like, what if Azure? I mean, we're talking about Azure Front Door being down, but what if Azure Traffic Manager also goes down? What's our backup? Like worst case scenario? Then, what's your input? And did it happen? It's very rare, right?
Grab a book, go to a park, read a book, because if Traffic Manager is down, then Azure is completely down. You don't have any type of services. So just enjoy your time and wait for Microsoft to get it back working.
Yeah. It's hard to explain. I mean, if you get that question from other perspective, it's hard to explain. So it's always like, because it's very rare that I've heard that Azure Traffic Manager goes down, because the entire backbone of Azure is about networking. So yeah.
All of the backbone is built on Traffic Manager. So if Traffic Manager goes down, then everything is down.
Yeah,
Let's face it, we
exactly.
don't have service at
No
all.
Microsoft.com.
So this is also a very good topic.
I know, yeah.
If you don't have your one of the big hyperscalers, and again, I work with Azure, I work with AWS, I work with GCP also. If one of these hyperscalers fails, what do we do, right?
Yeah.
Because we don't have the workloads on-prem anymore. We've put it on the cloud, on someone else's data center, right?
We go back on prem again.
Yeah,
Just
but
worst case.
how long would that take, and to
Yeah,
what costs?
exactly.
Would you find servers to put on the rack again to create your on-prem? I don't know.
Mm. It's like going back to the dinosaur age, but yeah, it's very interesting questions. I get a lot of these interesting questions as someone also being known as Azure expert who wrote a book about Azure. I mean, I'm asking back also to fellow Azure MVPs like you that worked in the technology for 30 years plus, longer than me. But it's very interesting questions that I think we as Microsoft MVP has something to say also in terms of giving feedback
Yeah,
and working in the field.
yeah,
I think you
true.
agree. Håkan probably agrees in that working with AI and Azure space as well.
Let me just add one little comment for the ones that are learning or want to start using Front Door. I think that's important because of all of these mechanisms that I've described. Now doing something on Front Door, you do a configuration, it takes like 30-40 minutes to actually apply. Okay, so be patient, do the configuration, go grab a coffee, do something else, and then come back. Okay. To create this demo, I had to deploy the infrastructure not today. It was deployed a few days ago to give it time to create everything, propagate everything, just to have this simple demo. Okay.
I
So
can relate to that. I did actually a migration of custom domain from one endpoint of front door to a new endpoint that we had to do a bit of reverse engineering. So I can relate on the waiting time, especially on the back-to-back changes. So yeah, thanks for your time, Pedro, to devote on preparation of the demo with the front door delay. So thanks so much. But and also sharing about the outage and best practices, your lessons learned. We truly appreciate your time, especially in the sunny weather in Portugal, and you sitting on your computer. Thank you so much. Also to Håkan. But anything else, Håkan, before I share our like after session? I don't know if we have time for that, but we already tackled everything. But we can connect on Zoom in case someone else wants to join briefly. Do you have
Yeah, I guess
anything, Håkan?
let's connect on Zoom here and see.
Yes. Okay, Pedro, thank you so much. And to everyone that joined us, we appreciate your time. Those that left feedback and even questions, especially to me that asked a lot as well. But join us in our after session Fika with Zoom. So we use the same Bitly linked and QR code to for that. And let's continue our conversation there. If you show up, then we're gonna have more discussion. But otherwise, that's it, Håkan, Pedro. I
no,
hope that you all have a great weekend.
thank you.
Thanks.
Yes, have a great weekend, everyone.
Yes, thank you. Bye bye.